polynomial function of degree n is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 times x to the n minus 1, so on and so forth, until you get to a sub 1 times x plus a sub 0. Now these three dots here just mean follow the pattern. So though we didn't draw it because we don't know how long this is going to be, it depends on n. The next term, the first, the dots, the first term that hasn't been written in that would follow the pattern would be a sub n minus 2 times x to the power n minus 2. So specifically, if we look at the case of n equals 4, a polynomial function of degree 4 is of the form f of x equals a sub 4 times x to the 4 plus a sub 3 times x to the 3 plus a sub 2 times x to the 2 plus a sub 1 times x to the 1 plus a sub 0 times x to the 0. Now we can pick any numbers we want for a sub 4, a sub 3, a sub 2, a sub 1, and a sub 0. There are these 5 separate numbers, a4, a3, a2, a1, a0, that we just need to pick. For example, f of x equals, we picked the number 12 for a sub 4. So f of x equals 12x to the 4th plus negative 2x to the 3rd plus pi x to the 2nd plus negative 8x to the 1st plus 31 is an example. This is a specific polynomial function of degree 4. Now, polynomial function of degree 2 is less scary. It's following this format up at the top. It is an f of x equals a sub 2 x to the 2 plus a sub 1 x plus a sub 0. And because there's only 3 numbers to pick, a sub 2, a sub 1, and a sub 0, we've typically seen this in the format just, a, b, and c instead. So f of x equals ax squared plus bx plus c. It's just, if we did that for degree 4 or degree 7 or degree 26 or then degree 27, we're going to run out if we just use letters a, b, c. So that's why they're just called a sub 1, a sub 2, a sub 3, and so on. Okay, so as an example, 3x squared plus 4x plus 5 is an example of a polynomial function of degree 2. So it's either a, b, c are 3, 4, and 5, or a sub 2, a sub 1, a sub 0 are 3, 4, and 5. So we've dealt with polynomial functions of degree less than or equal to 2 before. Here it is again, a polynomial function of degree 2. It's of this form, of this format, or of this shape. And this is called a quadratic function. Its graph happens to be a parabola. If you looked at a polynomial function of degree 1, it's of the form f of x equals a sub 1 x plus a sub 0. And you just have to pick a number for a sub 1 and a sub 0. Those would be the m and the b. This is called a linear function. Its graph is a line, not a parabola. I will fix that here. This should say line right there. The main goal of today is, what about polynomial functions whose degree is 3 or higher? So we've dealt with degree 2, but what about degree 3? What about degree 4? How do we graph these? So this key piece of terminology will be useful. You may have seen this before, but let's just make sure we're on the same page. If c is an x value that makes f of c equal to 0, then c is called a root or a 0. It's kind of funny that c, even if c itself is not the number 0, is called a 0. So if c is an x value that when you run this through the function f, you get as an output the y coordinate 0, then the x value is called a 0. So for example, let's look at f of x equals x minus 4 times x minus 7. Now x equals 4 is a root or a 0 since f of 4 equals 0. If you were to plug in 4 for all the x's here, you'd have f of 4 is equal to 0 times negative 3, which would be 0. Okay, so since f of 4 simplifies to 0, x equals 4 is called a root or is called a 0. It's funny to call 4 a 0, but that's the language that gets used. Similarly, x equals 7 is a root or x equals 7 is a 0 because f of 7 equals 0. When f is written in factored form, like our example here, x minus 4 times x minus 7, it's a lot easier to spot what the zeros are. So if you're given f of x equals x squared minus 11x plus 28, I think to find zeros, it's actually a lot nicer to just factor first and write it as x minus 4 times x minus 7 instead.